Good day to you, people of the internet. I'm the legendary Josh Wolf, as seen on the internet, here with my trusty sidekick and son.
Prahlad.
And we're working on MCT1 today. So we're doing a bit of work around the state management, and for that we're using Nanoflux, which is a very minimal kind of flux architecture Redux type library. It's about 3.5K when it's minified, 1.5K when it's gzipped. We were actually using Nanoflux-fusion, which is kind of an opinionated library on top of Nanoflux, and you can get it from GitHub. It's made by this gentleman here, Ohega, who is from Brazil, according to his profile. You can also get it from NPM, and there's a bit of an explanation of Redux and the kind of state reduction pattern, immutability, all the kind of goodness of functional programming. So particularly for the state that we're modeling in MCT1, you want to talk a little bit about what kind of state we're modeling?
Yeah, so we're modeling type 1 diabetes. So we have the BGL, we got the rapid acting insulin, we got the basal insulin, and the carbohydrates that's on board. That's all of it.
Yeah, and we might have to do like a digestion queue to digest individual foods over time. But we can look at that later. Let's just get this thing up and running. So we're putting all the state into a directory here called state, index.ts. We're writing this in TypeScript. So here we're importing the Nanoflux-fusion library. Then we're creating a fusion store. So you get the fusion store from Nanoflux, the Nanoflux object. We're exporting it from here. So the rest of our application can import the fusion store from this file. This is basically just from the let me show you here. Basically just from the demo kind of code. Middleware interface, no. Async, no. This one here. So basically this is the example code from NPM or from GitHub, and then we're just modifying it to fit. So this is a subscription, and we'll do things like subscribe the blood glucose meters and stuff here, and effects and things. Here's our fusionator. So we create a fusionator, and in here we have our state reducers. They are functions that take the previous state and a change to the state, and then they return a new state. So here's one that changes the BGL. So it takes, automatically takes the previous state and a delta. So either a plus or a minus BGL. So then what it does is it calculates the current BGL by pulling it out of the previous state. And then the new BGL is whatever the current BGL is plus the delta. So if someone passes in -2, that would be, let's say that the current is 4, right? And then we pass in -2, what would that be?
2.
Yeah, that's right. So if you add a negative number to a number, it's the same as subtracting it, right?
Yeah.
So we can just use addition to do both up and down. We don't need to return the entire state. A partial state will be merged. A built-in feature, the new state is being frozen deeply. Remove item. So here's the, this is the demo code from the example. Now let's do change rapid insulin, right? So instead of remove item, we'll make this one into change rapid insulin. So it takes the previous state. It's going to take a delta. And in here, so we don't need to worry about that, we're going to say const current rapid insulin. Actually, you know what? We could probably do it like this. Control C. I think we can do this. Rapid insulin on board equals previous state. You've seen that before? Okay, so what this is this is the same as doing this, right? This is called object destructuring. It's a feature in ES6, and obviously you can also do it in TypeScript. It's the same thing as doing this. Previous state.rapid insulin on board. So you could write that. So we take the previous state, we grab the rapid insulin on board out of the state, and we put it into a local variable called rapid insulin on board. But you can do it as a shorthand method like this. It's a new language feature. You put these curly brackets around it, and what it means is we're going to create a new local variable called that, and we're going to populate it with previous state dot rapid incilin on board. Pretty cool, huh?
Yeah.
Yeah, it just saves you having to type that, because otherwise you're just typing the same thing twice, right? It's
Yeah.
like, yeah. It does make it a little, if you haven't seen it before, it's kind of like, what's this? What's that doing, you know? But yeah, you just got to know that when you see those curly braces, that is dot on there. So we'll do it like that. In that case, let's do the same thing up here, hey? So what we'll do is we'll change the name of this. So we're going to rename that symbol to BGL, like that, right? Dun, dun. And then we can do the object destructuring here. So we take this off. That gets the BGL into there. New BGL equals that. And then return BGL is the new BGL. Okay, cool. Make sense? Kinda.
Yeah.
Cool. Okay, so filter copy, var filter creates copy already. Okay, we're not really doing that. So we're basically doing the same thing here. We're going to go const new rapid insulin on board equals. You know, another way we could actually do this is we could do let, and we could directly mutate this thing. See, we could do it like this. I'm going to just, we could do a let. So the difference between const and let is that if you say const, you can't change the value. But if you do let, you can reassign the value. So we could do this. We could do rapid insulin on board plus equals delta. That's another shorthand. That's a shorthand for this. Rapid insulin on board equals rapid insulin on board plus delta.
Oh, it's much easier to write.
I know, right? Because you're just doing it equals itself plus another number. Why don't we just do plus equals delta? So that's...
Wouldn't it be equals plus?
No, it has to be plus equals. You can do minus equals as well. See, watch what happens if I go equals plus. Okay, I'm not getting an error. What does that even do? Let's find out. So we'll start node down here. If we go let a equal 4, okay, and then we'll go a equals plus 3. A is 3. Oh, I see. It's the same as going a equals negative 3 or plus 3. See? 5, a is 5, so a equals negative 5. Yeah, you see? So that's why you can't do equals plus.
Okay.
You got to go a plus equals. Now, if I plus equal 5, what will the result be?
9.
Okay, have a look closely. What's the current value of a?
It's going to be 0.
Okay, there you go, 0. Okay, that's why you can't do equals plus. Sorry, equals plus. That's why you can't do equals plus. That's interesting, right? Because you could end up with an error in your code because you think that you're adding the number here, but you're not.
Yeah.
Yeah, plus equals, like that.
Because the other one you wrote had the equals then the plus, so I would have thought equals plus.
Yeah, no, it does not work. So here's the cool thing about this, right? Doing it that way, you can now just return that. And that's a shorthand for rapid insulin. That's the same thing as doing that. But because they have the same name, we can now do that. We could make it like that, right? That's pretty simple. See, like if you have a look at, hang on, let's format this thing. Format. Now, if you have a look at the difference between these two, right? I'll get rid of these comments. Like this. Now, if you compare the two of them, they basically do the same thing. They take in the previous state, and then they add the delta to one of the aspects of the state. In this case, the BGL. In this case, the rapid insulin on board, right? Now, the difference between the two of these is, you see how we have to return BGL, new BGL here?
Yeah.
And we can just return rapid insulin on board. The difference is that here, we're actually mutating this variable. So we're changing the value of it.
Okay.
Whereas here, we don't change the value of anything. We create a new BGL here, and then we return that there.
Wouldn't it be easier just to mutate it?
Probably be easier to mutate it. The thing about doing mutations, though, is that they can lead to difficult to debug errors, mutations. Because you see, the thing about it is that when you do that, like here, BGL is only ever one thing, new BGL is only ever one thing. It can only ever be set here, nowhere else. So you don't need to worry about it like later on in your application being something else. It's only ever going to be that. It's like reliable.
Yeah.
Whereas once you do this, even though, see, we define it, we mutate it, and we return it in 3 lines. There's like no opportunity for anything to happen.
Yeah.
But imagine if this was like longer, and there was different things happening, right?
That's only 3 lines.
I know, but that's the thin end of the wedge, right? I think it's better to just like as a discipline stick with non-mutations.
Okay.
Yeah, because it just makes your life easier as you go along. So what we're going to do here is we're going to say const new rapid NCLN on board equals the rapid NCLN on board plus the delta. And then we're going to have to return this new rapid NCLN on board like that. Dink. Yeah, still 3 lines, but we got immutability. Yeah, no mutations, no mutation of state. It's a good thing. It's a good thing. Okay, so let's do the same thing for change the basal insulin, right? It's basically the same thing, so could actually just cut and paste, change this name here. Yeah, okay, we'll just do it like this, basal. And I think that we can go in here and we can go rename this symbol, yep. And this is the cool thing about TypeScript, it recognizes basal. And then this one here, we're going to rename this symbol basal. Yeah?
Why doesn't it do that for the top one?
Why doesn't it change it up here?
Yeah.
Yeah, because it's not just doing, see, if I was to do like find all instances of this, right? If I go Control-C, Control-F, find, oh, now we changed them, right? Let's do previous state. There you go. Look, see how it identifies that these are all previous state?
Yeah.
But if I go like this and I go rename this symbol, call it previous state 1. See how it only changed that one?
Yeah.
Because it knows that this one here is different from these ones. Because it's not just doing like a grep or a find of the text pattern. It knows that this is a function, this is the name of the parameter in the function, and this is the use of the parameter in the function.
Okay.
These ones here have the same name, but they're a different thing. You know, like just like in the real world, there are some things that have the same name, but they're a different thing.
Night.
Hmm?
Night and night.
Like a kenite and a night.
A kenite.
Yeah. Like kenite, like that, and night.
It's night, not kenite.
Oh, it used to be pronounced kenite. Like when we were in Norway, and I went and I said, "Hey, can I get I need to buy a knife," and then the guy's like, "Knife." Knife. That's Norwegian for knife. Knife. And it's spelled like this. Knife. Or maybe it was like that. Knife. Yeah, knife.
That's just K-knife.
K-knife. Yeah, knife. So, things that have the same name. Oh, why is that giving a problem? Okay, we've got missing a comma there. They have the same name, but they're different things. You know, like there might be someone else called Prahlad, or there's probably a bunch of people called Josh.
Yeah.
But they're different people, right?
Yeah.
And so same thing here. Same name, but they're different things. But when you're using TypeScript, it can understand. It's the whole thing about static typing is tools that can reason about your code while you're writing it. Okay, so we've got to change basal insulin here. And here's where we export this mutation method, this actor, by getting the fusion actor by name. And it's good that we do this here and export it from here because there's no type checking on this. Like I could write literally anything here. Control C. I could write this and I could say, let's just call it change insulin and then this. No type checking.
Okay.
So there's a real opportunity to get things wrong when people are just like typing things that have to be exactly right, you know? Like you might accidentally, I don't know, do something like this. That won't work, but you can't get any errors about it. But because we do it right here, we can then, we could write a test actually. We should write a test just to prove this piece of code, and then we know whenever we import it anywhere else that it's reliable. Okay, so change basal insulin. What else do we need to do? Change carbs method. Like add carbs or deplete carbs, right? Okay, so we'll do that. So just say change carbs method. Change carbs?
Sure.
What's that item? Yeah, that's a dumb name. Take off item. So go down here. Yeah, okay, there's no, see how there was no error for that?
Oh, yeah, you've never found that.
Yeah, I would have found it eventually, but. So change carbs, previous state delta. So carbs on board, I'm going to copy that. We'll go in here and then we just go rename that symbol to carbs on board. Change this symbol here, rename symbol to, I just saw another error that we've got to fix. It's called new carbs on board, right? New carbs on board.
Why do you have such weird casing of letters?
Well, look, each new word has a capital, but the first one's lowercase. Usually when you put it like a capital at the beginning, it's for like a class or a singleton object or something like that.
Okay.
Yeah. I just saw something else that we needed to change. Rapid insulin on board, rapid insulin on board. Yep, get fusion actor, change basal, change rapid. Here, see that? Yeah, basal insulin on board. There's no typing for the state in here.
So if something went wrong, it would just say silent.
Yeah, exactly. We could actually add something here, right? We could say like a T1 type. So we could go interface, T1 state, right? And then a T1 state consists of carbs on board, right? Which is a number. And I put a question mark there because it doesn't always have to be there. Rapid insulin on board, number. Basal insulin on board.
Yeah.
Anything else? BGL. And then what we do here is we go down and we just specify that each of these should return a T1 state. Right? Yeah. And then what this will do is it'll type check it for us. T1 state. Okay, well that actually that wouldn't have caught that actually. Like if I have rapid insulin, oops, I accidentally returned the wrong one. Can't catch that. You can't catch everything. But if I do that, it's going to say T1 state, beta insulin on board does not exist in type T1 state. That's cool, huh?
Yeah.
Because that can catch some types of errors there. So we just created that nice little interface for our state, and then we've got a state here. Okay, great. So takes a previous state. We can also do this. We can say that the delta has to be a number. And that means that when we call these methods from other parts of the application, they'll be type checked. And if we try to pass in something that's not a number, it'll give us an error. Gradual typing, this is called. Not sure about that. Okay, I think I can get rid of this error like this. Nope. No, it's a value.
You have to put a number.
No, I could do this, right? This equals this as n. No, I can't. Still there. No, I'm not sure how to get around that. Maybe I need to do this.
Is it because it's in italics?
No, it's a special. This is a special variable, and it's a very special variable in JavaScript. Okay, so here we go. We've got our change BGL, change rapid insulin, change basal insulin, and now we've got one for change carbs as well, right? So we're going to export change carbs, and then we're going to get from here change carbs. Cool. There we go. Not sure what to do about that. We might Google it later. Okay, great. So now we've got our reducers that mutate the state, and one of the things that we could do, well, we should write a test for this. So let's do that now. So we go index.test.ts like that. We're going to write a test. It's going to be, so describe test state reducers, right? Okay, so it's a function. And in here we're going to say here's the first test, right? So test shape of exports.
Okay.
Yeah, we're going to test the shape of what we expect it to be. So here we should say const t1 state equals MCT1 state, we'll call it. MCT1 state equals require index. Actually, we should do import star as MCT1 state like this from index. Okay, cool. Now, we should say expect. Now if I go MCT1 state, now watch this. Dink. Pretty cool, huh? Okay, so we should expect the basal, well, we should expect the fusion store, I'm going to say to be truthy. It's probably not a very good test, but it just means that it's going to be something. Let's expect all of the stuff to be truthy to start with.
To be truthy.
Yeah. Can I say to be a function? Nope. Okay, to be truthy. It means that it's something rather than nothing. Like if it was undefined, it's not truthy.
That's such a weird word, truthy.
Truthiness. To be truthy, expect MCT1 state dot, which one did we not do? Change BGL?
Yeah. And carbohydrates.
And carbohydrates, okay. Okay, expect MCT1 state, change carbs, yep. To be truthy, ta-da, okay. Now if I now go npm test, it's going to work. There we go, run state, one failed, two passed, okay, one of them has failed. Which one was that? Cannot find module Nanoflux-fusion from index. Okay, cool. So I probably have to do yarn add Nanoflux-fusion, this. I think I forgot to add it to the project. npm test, here we go. It's running the tests. 1 passed, 3 passed, 5 passed. They all passed. Cool, huh? Okay, so let's do this. Okay, let's test the actual state. Test initial state, right? Okay, so MCT1 state dot fusion store dot get state, okay, dot BGL to be 4. see, we define it here as 4. And pretty sure it's available via fusion store.getState. So in our test, we do fusion store getState. Okay, you got to call that like that. Cool. Let's try it,
Okay.
npm test. Okay, it's running the tests, and then we'll try mutating it and see if we can get a different state. Okay, cool, passed. So then here we should be able to do MCT1 state dot change BGL, right? And we should add 2 to the BGL, and then we should expect the MCT1 state dot fusion store. Maybe we could just export it directly from there to make it easier to get to. Anyway, you know, we would just export get state like this. We would just go, we could do it as a one-liner, which would be kind of cool, like this. Watch. Export const get state equals, it's a function that takes no parameters, and it returns fusion store dot get state, like that. See? It's functional, it's a lambda. It's just a single one-line thing. It's not anonymous. It's a maybe lambdas are anonymous. Anyway, it's a single function, get state. It takes no parameters, and then it just returns the get state. So instead of having to write that, we could just now say that. We'd even go further and do BGL and stuff, but we won't optimize to that level yet. 6, because we're not 100% sure on how we're going to be using stuff yet. Let's have a look. One failed. Okay. All right. Which one failed? One failed. Okay. So it says here, items undefined. State index TS9. Oh! When we mutated it, it actually fired the subscription.
Okay.
Okay, so there's something to be aware of. We'll have to be careful when we set the subscriptions to keep it testable. Okay, so if we run the test, I think it should pass.
Nope.
Nope. Okay. Initial state. Okay, so in here it failed. Well, we know this one passed before, right? So expected value to be 6, received 4 object arguments.
Because you have both expect state to be 2 different ones.
No, because see, in between we mutated it, right?
So it still says it expects it to be 4.
Let's get Ghetto here and do this. Let's just do this. Oh, this is real ghetto. Okay. Declare console as any, whatever. Const. Okay. npm test. I'm going to log out the state. There's something about that state that it's probably got a different shape than what I expected. Let's have a look. Here it is here. Look, we console log out the state. Yep. Oh, look at that. Oh, you know what?
What?
I'm pretty sure okay, it's our mutation methods are not working properly. Okay, look, here's the thing about it. That might actually be stored as a string rather than a number, right? So in our change BGL method in here, we should do this, a couple of things, right? I think we need to console log out previous, hang on, let's just do this. I think there's 2 problems here. That delta is actually not just the thing. I think the delta might be an array or something. If we go here, console.log type of BGL. See if it's a string or a number, right? BGL type. And then the second thing we should do is console.log delta, and then actually log out the delta itself. There we go, npm test, ready? Okay, failed as we expected, but let's have a look. Here's our logs. Okay, BGL type, it's a number. Okay, and then delta, oh look at that. Delta is actually not a single thing, it's an argument sum. So you can actually pass in, it's actually an array. It's an array of numbers. So it's actually an array of any, I think. Yeah, it's an array of any. See, we'd need to do this. It's a bit ghetto. So maybe we do this, args, like that. What does Chuck have in here? Yeah, look, he has args. Yeah, arg0. Okay. So here we should do this then. Const delta equals arg0, just to make it explicit what we're doing. Like that. Okay, according to my calculations, this should now pass the test. There we go.
Nope.
You don't think so?
Nah.
Why not?
Told you.
Comparing two different types of values, expected number but received string. Expected 6 but received 4 object arguments.
I think these are all trying to call to the same one.
No, it's because I didn't do that up here, that's all.
Oh.
That's all. If I do args, and then I say it's going to be an array of numbers. Okay, this time it should pass. Or your money back. Or your money back.
Yeah,
Okay, cool. It worked. Yeah, and here's the good thing about it is, not only do we have code that works, but we now also have a test that lets us know that it works. So when we change things in the future, the tests are still here, and they can tell us if we break something else later. Because as we write more code, you know, we could accidentally break something that was already working before. Happens all the time. It's called a regression. So by having the tests in place, it means that, you know, we can go forward confidently that we'll notice if we break something that used to work.
But shouldn't it already tell you that without making your own test?
How would it do that?
It just sees that there's something wrong and it doesn't work there.
No, because, you know, the thing about it is none of this stuff knows what we want it to do.
Oh, yeah.
So what a test is really is it's like an explicit declaration of what we expect that this is what we want it to do. We expect that this should do this. We expect that this should do this, like that, right? So here we're actually creating an expectation of what the code should do. So now it can tell us. Whereas before we're just writing code, but it's like, I don't know what you're trying to do.
Yeah.
Yeah. So that's what tests are for. Okay, cool. Well, look, we got the state reducer working. And yeah, we're using this Redux pattern. It's a very nice pattern for making apps that are easy to reason about, you know, and as they scale up in size and complexity, they're manageable. So that's probably enough for today's little foray into the MCT1 code base. I'm the legendary Josh Wolf, as seen on the internet here with
Prahlad.
Boom.